So this learning target says I can define electronegativity and compare these values of different elements. So first thing, we need to be able to define this term, electronegativity. So what does this actually mean? If we measure the electronegativity of an element, we are measuring how badly an atom wants to gain electrons. So atoms that really want to gain electrons have high electronegativities, and atoms that have do not want electrons at all have very low electronegativities. So that's the definition. What we need to know how to do next is compare different electronegativities of elements on the periodic table. So, what's the trend for electronegativity? Well, as you move up the periodic table, up a group, electronegativity, which I'm going to abbreviate as En, increases. What that means is that if you were comparing lithium and potassium, for example, which element would be more electronegative? Lithium would be. Lithium has a higher electronegativity because it's higher up on the periodic table. What about when we go left to right? Well, as you move across a period from left to right, electronegativity also increases. So therefore, if we were comparing two elements like oxygen and nitrogen, which element would be more electronegative? Oxygen is more electronegative because it's further to the right. This works for the entire periodic table except for this far right column. The noble gases are special. They have no electronegativity. They have zero electronegativity. And that's because they don't want electrons. They don't want electrons because they already satisfy the octet rule. So they don't need to gain any more electrons. They're good to go. So therefore, the most electronegative element is fluorine. It's the element that wants electrons more than any other element on the periodic table. How do we apply this knowledge? Let's look at two examples. So number one, which of the following elements would be the most electronegative? Okay, what does that mean? We're thinking about the element that wants electrons the most. And we know that that occurs in the top right corner of the periodic table. So what we have to do is find these four elements on the periodic table: carbon, aluminum, oxygen, and calcium. So once we find those, you can check on your periodic table to find these four elements: carbon, aluminum, oxygen, and calcium. Okay. Here's carbon, here's aluminum, here's oxygen, and here's calcium. The four that are, the one that's the furthest to the top right is oxygen. So out of these four elements, oxygen is the most electronegative. Let's try another problem just for practice. Which of the following elements would be the least electronegative out of these four? Krypton, potassium, silicon, and oxygen. So krypton, Kr, potassium, K, silicon, Si, and oxygen, O. So go ahead, pause the video, try to answer this question by yourself. So we're trying to find the element that's the least electronegative. So refresher, what does that actually mean? It wants electrons the least. Or another way of saying that is it doesn't really want electrons at all. Which of these elements doesn't really want to gain electrons? So let's find these four elements on the periodic table: krypton, potassium, silicon, and oxygen. Well, if you do, you'll notice that krypton's here roughly, oxygen's here, silicon's here, and potassium's here. So we know that as you go up and to the right, electronegativity increases. So if we want the atom or the element with the least electronegativity, we want the element to the furthest bottom left. So that looks like it would be potassium. However, potassium is not the right answer. Because there's a little trick here. Krypton is in group 8A. It's a noble gas. And we know that the noble gases don't want electrons at all because they already satisfy the octet rule. So krypton would have the least electronegativity, the lowest, it's the least electronegative because it doesn't want electrons at